Really nice to be here. I'm really grateful for the organizers to give me an opportunity to give this presentation for you. And I will talk about microservices and Scala. So before I start, let me say a few words about myself. So my name is Paweł Bogdan. I'm staff software engineer in Grid Dynamics. I program mainly in Scala, but I have really big, very strong background as a Java developer. I also received PhD in mathematics. I know this is irrelevant, but I like talking about that. So maybe one personal thing about me, I really like listening to hard rock during work. Not only during work, but especially then. So again, let me share my experience with you, because I think it can be relevant for my further speech. So I started learning to program in 2006. I am so old, so I started programming in Pascal. I remember this blue screen I will remember it for the end of my life. I started my first commercial experience in 2011, and I started as a Java developer, and I continued this career until 2015. In meanwhile, just after I defended my master's thesis, I started PhD studies. And even after defending my PhD thesis, I continue my academical career. But a part of that, I also gained some experience as Python developer. Yes, this Python sounds very crazy, but during my PhD research, I also used Python. Okay, as you probably know, working in two places at once is very hard, so I quit both those places and restarted my career as a Java developer. And in 2022, I joined Grid Dynamics, and then I started gaining some experience in Scala. So for now, I program mainly in Scala. So you can ask why I am here. So this is a very good question. So let me share the thought I heard somewhere some time ago, that there are two main reasons why people give presentation at conferences. So first of all is that the person has very big expertise and wants to share the knowledge. The second one is that the giving a speech, giving a presentation at conference is the opportunity to learn something new. As you saw, I'm not really experienced in Scala, so the first case is definitely not my case. And in fact, I wanted to learn something new, and it was a very nice opportunity to gain some additional knowledge. Moreover, my wife keeps saying that I like to be admired, so this is part of that. Okay, so yes, we started very long introduction, so let's move to the main topic of the presentation. So I will start talking about monoliths and microservices. Later, I will discuss the topic of synchronous and asynchronous programming. Later, I will say something about Akka. I will show how to create a simple microservice in Akka. And later, I will show how Tapir can be used to make it better. And in the end, I will talk a little bit about Akka streams. Okay, so very often we say that there is new approach to creating a web application and new one. It is said that there is the monolith is example of old approach, and microservices are examples of new approach. But I don't agree with that approach, that distinguish, because I believe they are designed for other purposes. So we can we can compare monoliths to big warship, which is designed to perform very strong operations. And microservices can be considered as Navy SEALs, US Navy SEALs. So as you can see, they are nimble and can operate very effective under the cover. So I believe that warships and Navy SEALs are designed for different purposes, and so my monoliths and microservices. And as we are here in JVM conference, so you probably know that the main tool, the tool of the first choice is Java with Spring. Recently, Kotlin appears to be more and more tempting. However, I would like to present you some Scala functional approach. So, as you probably know, because you are experienced developers, so usually monolith is just a big headache, while microservices is just the set of many small headaches. But I strongly believe that using Scala, at least some of those headaches can be changed into very successful solutions. But Scala, as everything, has its cons and pros. So let me list a couple of them here. So I believe that the biggest cons of developing application in Scala is very small community of users. Why is it a problem? Because, you know, small community means very few answers in Stack Overflow about potential problems. And maybe one other cons worth to mention right here is that there is too many tools and libraries. So, for example, those things I will show you today can be done in various different ways, and it's even hard to choose the library or framework which will be most suitable for your solution. It's not just like Spring, what Spring solves all problems and introduces much more. Okay, so maybe let's talk a little about pros. So I strongly believe that Scala provides a possibility to create very clean and maintainable code. Of course, and again, some digression, my brother-in-law to be, as my sister keeps saying, said once that when you write a code in Scala, you don't understand it after 2 weeks. And it's also true, because Scala provides a possibility to create very effectively and it has this possibility to create really complex programs, and without caution, it's true that the code can be messy. And Scala provides this possibility to integrations with other programming languages, with many tools, but as I said, Scala doesn't work with Spring. Okay. Question, before we move forward, let's pretend that we have fun and we are at stand-up party, so question to you. Have you ever used asynchronous programming? Okay, nothing. Okay, so what can you say about asynchronous programming? Okay. Okay. Did you like it or not? Okay. Okay, so yes, we have one experienced guy. Yes, me too. For first, I also had troubles with understanding asynchronous code. But let's see what are the main differences. So in case of synchronous programming, we have thread pool, and when the request is is received by this thread pool, single thread is used to handle it from the beginning to the end. So in case we have this blocking resources, this thread waits, is blocked until the resources return the calculated value. So as we can see, we have this blocking operation which demands more and more threads when there are many requests and this resource responds slowly. The asynchronous mechanism is maybe simpler to understand, but much more difficult to code. So we have this thread pool, but when the resource is blocking, so the thread doesn't wait until the operation is finished. It just calls, register a callback, and gets back to handle more incoming requests. And this asynchronous mechanism is usually developed using event loop. So as you can see, the background, the things happening under the hood in asynchronous programming are more complicated. And I would recommend to think very carefully if we really need asynchronous programming in our application, because there are many architects that say yes, we need to follow reactive way, asynchronous way, but in fact very often it is not the best choice. However, let's look at the example. Is it well? Do you see it very well? Is it clear? It's okay, great. So I would like to show you some differences in Spring, because Spring, as you probably know, supports synchronous and asynchronous mechanism as well. So, as you can see, we have ordinary REST controller, which has defined prefix path. We also have this endpoint definition, which is defined by HTTP method and also the exact path. In both cases, we have some client which executes a request to another service. In the example, I am considering it calls just WireMock server. But take a look. This is the first difference I would like to point you out, that this client, in case of on the left, is just REST template. And REST template is example of synchronous HTTP client. While on the right side, we have web client, which is example of asynchronous HTTP client. And another very distinguished, very visible difference is the result type of this method handling the request. In case of ordinary Spring, it is just response entity, while in case of asynchronous programming, reactive one, it is mono. Mono is just this object which allows enables this asynchronous communication. Okay, so Akka. Why I spent so much time on discussing asynchronous communication? Because Akka is built on asynchronous idea. Main tool available in Akka are actors. So Akka provides some abstraction over threads that there are actors which communicates asynchronously inside the Akka application. And this actor system is essential for all microservices, for all applications created using Akka. So let's see how we can build simple Akka web application, and let's compare it to ordinary Spring synchronous application. So for the beginning, let's check the client. So as you can see, in case of Spring, we create just REST template based on the configuration which is provided in the application properties file. while in case of Akka, we have something much more complicated. Maybe not much, but a little bit more complicated. So take a look. Very, very visible, very important difference is that this client in Akka needs actor system. And this is Scala magic implicit. There are arguments which don't need to be provided explicitly during execution of the method. It is very useful, but sometimes causes many troubles, many problems. And take a look at the return type of this execute method of the client. It returns future. So future, this is ordinary idea present in ordinary Java, that we have future object and we can read value from this future object. So this was very simple HTTP client. Let's take a look at root definition. Root. It can be a little bit misleading because in case of Spring, we usually say about controller. In case of Akka, root is much more frequently used word. So let's take a look. Here we have definition of prefix path for the endpoint defined inside this root. We also have defined the exact path for this endpoint we are creating. We have also defined the HTTP method we handle, and of course inside we have the logic of the endpoint itself. So in both cases we execute a request to another service. So this is we saw the client, we saw the root, so let's check how the main application looks like. So in case of Java, as we know, there is main method, which means what should be done by the application. In case of Scala, there are a few other options, but I believe the most commonly used is to create an object which extends up. And everything which is defined inside this object is executed as a main program. And in case of Spring, we have this magic annotation, which does everything we need to launch the application. In case of Akka, we need to specify many things manually by our own. So we need to create an actor system, we need to read configuration file on our own, we need to create a client, there is no such a concept as a bean, and we need to manually start HTTP server, which is also started by Spring under the hood by Spring owns, and we need to inject this root definition and client to the root definition on our own. Of course, there are mechanisms in Scala to implement dependency injection, but this is not the topic of this presentation. Okay, so as we can see, there are many differences between application written in Spring and this one written in Akka. So I would like to show you how Tapir library can be used to simplify the definition of our program. And Tapir is mainly used to simplify root definition. So let's focus on this root definition. On the left, you see this definition we created just before, and on the right is the newly developed root definition. So, as you can see, we have this prefix path defined. We have defined the exact path. We have defined the HTTP method we handle, and in case of Tapir, this is very interesting, we have specified the result type, the type of data which is returned by this endpoint. And finally, we have this definition of the logic implemented in that endpoint. Okay, so here, as you can see, we want to provide the same we want to use the same main application, so we don't change the signature of this method getRoots. So to be able to use this endpoint defined by Tapir, we need to convert this endpoint, well, exactly the list of endpoints, to Akka roots. So this is first difference. Also, maybe not Tapir itself, but the whole environment of Tapir provided some additional tools to create simpler HTTP clients. And here is an example of such a client. So first of all, we use this object basic requests. This object is provided by this library for HTTP client from Tapir, and we have this backend because there is the idea that we can call a request using different backends, and depending on the backend, this request is handled differently. And here we use future backend, so this means that as a result of the request we will get future objects, so this again is asynchronous HTTP client. And one last thing, we can see that this Tapir client doesn't need actor system. It uses a context executor, and this is maybe not common in Java, but this is a standard approach from Scala. So there is Scala global execution context which can be used in that place, and we can avoid using actor system. Okay, and one more thing, as you can see, in case of Akka, we had this feature of response, while here in the client provided by the Tapir, we can specify exact type of this data obtained by the client. Okay, and why using Tapir is recommended by me? First of all, we can generate the documentation of our endpoints very easily. So it's enough to add this additional endpoint, Swagger endpoint, and it's enough to add this endpoint to list of our endpoints to get an endpoint which provides Swagger for all endpoints we defined in our application. So this is one very big advantage. The second advantage of using Tapir is that we can get rid of Akka. Yes, that can be silly, that can sound silly, but last September the creators and maintainers of Akka announced that they changes licensing of the Akka framework. So they said, because it used to be open source, but they said, if you earn money because of our library, pay us. So this getting rid of Akka is considered by many organizations using it so far. And thanks to Tapir, we can get rid of Akka very easily if we already started using Tapir. Just look. We have the same logic in both cases. On the left side, root definition for Akka. On the right side, the root definition which is not using Akka. But so the logic itself is the same. But we have another type of the result type of the getRoot. So this strange generic type full is exact type of those endpoints generated and defined by Tapir library. So we can just get rid of this translation of Tapir endpoint to Akka root, and we also can get rid of actor system. But we changed the result type of getRoot of this method here, so we need to adjust the main program. And the adjustment is really simple because, as you can see, we used this HTTP server provided by Akka, but now we can use HTTP server provided by Netty. And Netty, as you probably know, is widely used in Java world. It is this default service used by Webflux, and Webflux is this module of Spring which allow us to create asynchronous applications. And as you can see, we don't need this actor system, so we successfully get rid of Akka. Okay, but there is one more topic which needs to be discussed in that situation. Okay, again, question to the audience. Have you ever written a program which needs to operate on very big files uploaded by the user? Okay, I know this is not often scenario, but as you probably know, when user uploads the file, we need to get all the file on the server side. So we need to keep it in memory, and after we gather all the file in the memory, we can do something about that. But in case of very big file, it doesn't work. It is bad approach in case of very big files, or in case of many users uploading small files at once. So the solution can be Akka streams. So the idea of Akka streams is to upload file step by step. So you don't upload all file at once, but you upload chunk of file. Application does something about this file, this part of file, and gets another part to process it further. So this is a simple example of web application in Akka, which just gets the file from the user and saves it to the local file. But it can be easily changed to application which gets the file from the user and stores it in, for example, S3 bucket in AWS. So take a look. We just like before, we define path for our endpoint. We define the method. Now we use post instead of get, but this is very simple change. We also add this information about result type of this endpoint, and we add this very nice feature that we define an input for the endpoint. And we can define this, and using that approach, we can provide using specific header, get parameters, and body of the post request. And here we have not string body, we have Akka stream text body. So this is this example of using stream instead of just data. And take a look at here. So in this endpoint, we have defined the logic. Before, in previous example, we executed a request to another service. In this example, we use some handling method defined in the same file. So as you can see, the most important part is defined here. So we have input stream, and we redirect the stream with the file, with this file from user to the local file in our system. Of course, we can do anything we want, anything we can imagine about this stream. And while the stream is analyzed completely, we have this map method. And in map method is used one of my favorite features of Scala language. This is pattern matching. So, and depending on the result in this result of the of the analyzing the stream, we return OK or we return error. So this is very specific use case of Akka stream, but we are not doomed. There are plenty of solutions available here, and one of them is Zio streams. So Zio streams is basically some alternative for Akka streams, which is also integrated with Tapir library. So we can very easily rewrite our application to use Zio streams instead of Akka streams. But it demands a little bit more effort. So in root definition, we have actually two differences. One, we change the type of the stream, and also we change the method name, which is used to define the logic of the endpoint. And this method responsible for handling file is very simple, because very simple but different. So as you can see here, the result type is different. But even though the body of this method is very similar, because we just use the stream and redirect it to the sink. Sink is the common word in stream world, which defines the end, the place where stream should be in the end. And we have this logic here. This logic here also, again, is responsible for handling success and failure. And even though this logic is different, we still can return string body as the result of working of our endpoint. And this we are already done, because the last thing we need to do is just to update main application. So in case of Zio streams, we extend another class. So we extend class provided by Zio, so it means that we need to override the method which is defined there. So in Akka, ordinary Akka application, we just defined a HTTP server and started it. In Zio, this definition is split in two places. So one place is to provide the application definition, and another part inside this run method is to start service which serves this application defined in separate place. So that's it I wanted to show you. So maybe as a summary, Tapir library is very powerful library which defines an abstraction over endpoints, over web applications, and provides the possibility to change the backend used under the hood of our application. So if you have any questions, I would like to answer them now. And organizers of the conference provides the marks for the most interesting questions, and the choice is subjectively mine.
You mentioned at the beginning that Spring doesn't work with Scala. Why? It's still JVM language, so it should work.
How to say it? Scala has problems with this code auto-generated by annotations. So I didn't dig very deeply in that topic, but I tried and it doesn't work. Yes, but generally, in Scala we can use all libraries which are defined for Java, because, as you said, this is all inside JVM.
I have another one. Do you need Tapir with Zio? Zio doesn't have anything by itself?
No, I don't need Tapir with Zio. Zio can work on its own, just like Akka does. But I wanted to show you that you can define your endpoint using Tapir, and you can provide the handling this endpoint in whatever technology you want. So you can easily change this backend from Akka to Zio. You can also use cuts effect and FS2 streams as well, because they have already implemented this integration with Tapir library.
I wanted to ask, how big is Akka in the Scala ecosystem?
What do you mean big?
What's the adoption percentage?
I have no, I don't know. Sorry.
But I don't know. 90%, 50.
I would say is over 50, but
Okay.
it's just my guess because I didn't check such a data.
Okay. And I guess it's getting smaller because the changes.
I suppose so. There are many guidebooks how to migrate to something else, but you know, Java or Oracle also changed this licensing of Java, but we are still here. We still use Java in corporate world. So maybe initially the usage will decrease, but overall, I don't believe that that companies, organizations using Akka so far will be so willing to migrate to something else, because you know it costs, and maybe if you have very big system implemented in Akka, it can be cheaper to pay the owner of Akka instead of rewriting it to something else.
And on this question, Akka is free below some organization size, right?
I don't know the details of this licensing, but for sure, if you don't earn money on them, you can...
For educational use, it's free.
Yes, and for open source project, I suppose that it is also free. So,
Okay.
But yes, I didn't read all this, licensings after the change.
Okay, thanks.
So sorry, a correction for that. It's free up to 25 billion of revenue a year. And for open source projects, you can get like a special version of the license.
Thank you very much. So it deserves for MAG as well, because I wasn't prepared for that question. So thank you very much.
It's your description of the talk that inspired me to check.
Okay. Okay. Yes, please.
I can answer this first question regarding usage of Scala and Spring in one project. We have projects which use this setup, and it runs just fine. But it's sometimes quite awkward because Spring requires you to use Java beans, and it would be natural to use case classes in Scala, but you have to write manually some Java beans just to make sure that Spring works just fine.
But
for some, configuration beans and so on.
I saw very many discussion on Stack Overflow that it doesn't work together.
I guess I'm happy I haven't read them. And
okay. So is this an example of that? If something cannot be done, find somebody who doesn't know that, he will do that.
I'm afraid I'm the case, yes. So,
okay.
So we have it works, and we have some projects in which we, start Scala programming right in the, in the body of the project, and we leave the technical shell to be simply Spring Boot.
Really?
Yeah.
Okay, I need to check it out.
Okay.
It can be very useful in that case. But did you check if... Okay, so maybe it doesn't make sense to... Okay, thank you.
After all, this is just JVM code, and it works.
Yes, but I thought that...
You might have some problems if you try to do some asynchronous programming and try to mix Scala features and Java features, and this might be complicated. But if you just want to express your business logic in Scala, and to wrap it up as
But using Scala without futures is...
Why?
Okay, maybe I'm biased by my project.
We all are.
So I believe this also deserves a mug.
So maybe my question is, because Akka with their actors is really fast and performant. So what is the performance of Tapir with Zio? Is it really good as Akka?
I didn't check that, And you know, this is a rather proof of concept that it is possible to integrate that, and it works. But to be honest, I have no idea how performant it is. As I said in the beginning, I wanted to learn something, and obviously I learned too few for your questions. So sorry. So in that case, thank you very much for your attention, and I encourage you to visit our booth in the main hall. So thank you very much.